Quarter 3 review, similar figures. All right, two triangles are similar if they have corresponding congruent angles and their sides are proportional. So if angle C is congruent to angle F and angle B is congruent to angle E and angle A is congruent to angle D, that would fit the first part of the definition, corresponding congruent angles. Then to see that they have proportional sides, you'd want to find their similarity ratio. And if they're all the same for each side, then you know the two figures are similar. So over here it says state the similarity ratio from triangle ABC to DEF. So since this was the first that was named, that's going to be our numerator, and then DEF would be our denominator. So if I take side AC, that corresponds to DF, so 3/6. If I reduce that fraction by 3, I'm going to get a 1/2. So now if each corresponding sides makes the fraction 1/2, I know these will be proportional. So if I take the side AB and put its corresponding side in the other triangle, 6 below it, once again reducing, getting a 1/2, so far so good. If I then take this one down here, which corresponds to this one over here, 10/20, if I reduce this by 10, I get 1/2. So since all three sides are proportional, they all have the same similarity ratio, these are similar triangles. So triangle ABC is similar to triangle DEF. And the 1/2 also is letting you know that the triangle ABC is half the size of DEF. All right, so problem number 1. It's letting us know that triangle LMJ is similar to PNS. So we know these are similar because it tells us right up here. This is the symbol for similarity. It wants us to solve for x. So we're going to make a proportion to solve. So we want to have sides that match up. Since I'm trying to find LM, once again, looking at the name, that's the first two letters of the similarity statement. So PN is its corresponding side. So I'm going to make a fraction out of that. X/24. And that's going to equal another fraction. Now, since I chose to have x be in my numerator, that's information from this big triangle here, that means in my next fraction that I make, I need to make sure that the information from this big triangle is in the numerator. So I'm going to go ahead, I'm going to use this side, JM, and JM, which is the last two letters in the similarity statement for the first triangle, is going to match NS. So these two are corresponding sides. So the 45 is going to go in the numerator, the 18 is going to go in the denominator. Now I'm going to solve this by cross multiplying. 18 times x is 18x. 24 times 45 is 1080. Divide both sides by 18, and we learn that x is 60. So now we know this side is 60. Just remember that if you are choosing information from one triangle, say in this case the big one, and I chose it to be in the numerator, it has to be in the numerator for both fractions. Our next problem, once again, are two similar triangles, as we can see in the similarity statement above. They ask us to find x and then find the length of NL. So when we have a picture like this, sometimes it can be tricky to figure out which sides correspond to each other. And this is where looking at the similarity statement is really important. So I want to know, what does LM correspond to in this smaller triangle up at top? So I look, LM is the first two letters. So it matches the first two letters in the other triangle, which means it matches to LD. So if I'm going to make a fraction, a proportion to help me solve this, these two have to be in the same fraction. So I'm going to have 110 over 50. And that's going to equal the negative 2x plus 12 over the 70. And you'll notice that the numerator is made from the information from the bottom triangle, and the numbers in the denominator are made from this top triangle. You always want to be consistent. So we're going to cross multiply. So 110 times 70 is 7,700. Then we're going to multiply. We're going to have 50 times negative 2 plus 12x. We're going to distribute that. So 50 times negative 2 is negative 100. And then 50 times 12 is 600x. That's going to equal that 7,700 that we got from multiplying the 110 and the 70. Then we continue to solve the problem. We're going to add the 100 over. So we have 800. Then we're going to divide both sides by 600 to get x by itself. We're going to get x being 13. Now that we know that x is 13, we can plug it back in. So NL is negative 2 plus 12 times 13. So 12 times 13 is 156. 156 minus 2 is going to be 154. And that is the length of LN. Problem 3, they ask us to find the missing lengths. So in the problem on the left, you can see we have a triangle here. And in that triangle, you'll notice that we have a line here that's parallel to this side of the triangle. And when that happens, we can create a proportion to be able to solve for the missing side. So the information below is going to make one fraction, so 6 over 15. And then this one will make the other. I'm going to put x over 25. Now, once again, the order is important. Since in the numerator, I use the information from this small little piece here, this small little triangle, I'm going to make sure that the numerator has that pulling information from that same location. So this is all coming from the very small triangle. The 25 is coming from the bottom sections of the triangle. So now that I have it set up, I'm going to cross multiply. 6 times 25 is going to give us 150. X times 15 is 15x. Divide both sides by 15, and x is going to be a 10. For the second problem over here on the right, to create a proportion to solve this one, we actually need to find this length here first. Now, if we know the whole length of the triangle is 9, and this section over here is 3, this would have to be 6, because 6 plus 3 is 9, the total. Now that I have all the important information, I can go ahead and make my proportion. So I'm going to go this over this. So I'm going to have x over 6. And then the other triangle, I'm going to have 5 over 3. Once again, notice how I'm always using the same parts to be in my numerator as I am my denominator. I'm going to go ahead and cross multiply. So 3 times x is 3x. 5 times 6 is 30. Divide by 3. And x is 10. So find the missing length. So when you have 3 parallel lines and 2 transversals, these right here are the transversals, the ones without the red arrows, you can set up a proportion as long as you're consistent. So in this case, you'll notice that we have the total length 25 here, and we don't know this section. On this side, we know the total length of 10, but we don't know this section. Well, if we know the total length is 10, and we know this part right here is 6, this is obviously 4. So we know that part now. We need to make a proportion to be able to solve for our missing part where the question mark is. Once again, be consistent. since I need to figure out what this section is where the x is, I'm going to put that on top, and I'm going to put the 25 on the bottom. So all my information for the bottom part of this figure is in one fraction. That's going to equal. Now the corresponding part on the other side of the picture matches up with the 4. So the 4 has to go in the numerator, and the denominator has to be the total on that side, just like the denominator on the bottom of the figure was the total, the 25. Now I can go ahead and cross multiply. X times 10 is 10x. 4 times 25 is 100. Divided by 10, x is going to be 10. So now I know this length is 10. Proving two triangles are similar. There's 3 theorems that let us prove two triangles are similar, and that is AA, referring to angle, SSS, the 3 sides are proportional, and SAS, where there's 2 proportional sides and the angle between them is congruent. So as an example of how this works, this concept, we have angle B is congruent to angle Y, and angle A is congruent to angle X. By knowing that these 2 corresponding angles are congruent, these 2 figures are similar based on the theorem AA. Remember, similarity simply is that the 2 triangles look the same, one is larger than the other, is the visual idea that you're looking at. So over here where we have all 3 sides labeled, you'll notice they are not the same size. That's why these are similar figures and not congruent figures. But by seeing all 3 sides, we can make proportions to see if they have the same similarity ratio. So if I start off with having 5 over 10, looking at this side here and this side here, I get a 1/2 when I reduce the fraction. If I go with this side and this side, I make 5 over 10, which once again reduces to 1/2. And then if I go with this bottom side to this bottom side, I have 10 over 20, which once again reduces to 1/2. Since they all have the same similarity ratio, these are similar by SSS. And then the bottom one here, it's all about the side, angle, and side. You can see between the 2 sides they give us, the angles are congruent. Angle A is congruent to angle X. And you just want to make sure that the corresponding sides are proportional. So this side here and this side here are corresponding. So we have 3 over 9, and if we reduce it, we're going to get 1/3. Then if we look at the bottom part, we have the 5 and the 15, so 5 over 15. If we reduce it by 5, we get 1 over 3. You can see the 2 sides have the same similarity ratio, and the angle between it are congruent. So these are similar triangles by side, angle, side. So this problem says, prove why triangle ABC is similar to ABE. So looking at the problem, we have 2 parallel lines here, AC and ED, which means that they are parallel. This right here is what we call a transversal, which means that this angle here and this angle here are congruent because those are called alternate interior sides, which you can look up on your formula sheet that I handed you a few days ago. Also, by looking at this, we can see that since we have 2 lines crossing each other like this, we're creating vertical angles, which means this angle right here and this angle right here are also congruent. So we can prove these 2 are similar by the theorem AA. Now you notice that they put some numbers on the sides, and they want you to possibly think about the idea of using SAS, but sadly we don't know what this side length is here, so we couldn't set up the proportions to prove side, angle, side. We just didn't have enough information for that one. We did have enough information though for AA because of the alternate interior sides, which is angle A and angle D. Those 2 are congruent. And the two angles in the middle are vertical angles as well. So angle ABC is congruent to angle DBE. And that's why we can use AA. It then asks us to find the length of BE. So here they actually want us to find the length of BE since we've proven these two triangles are similar. So once again, you always want to make sure that you're matching up corresponding sides. So you can use the similarity statement to help you do that. So BC, if I look at the name, BC, the last two letters, match up to BE. So these two right here are actually the corresponding sides. So I'm going to make a fraction out of that, 54 over x. Therefore, by process of elimination, this side right here and this side right here have to be corresponding sides. Now, since I used information from this triangle for my numerator in the second fraction, I have to continue to use information from that triangle in my numerator. And the 54 would be on the bottom. Now we're going to just cross multiply and solve. So 54 times 54 is 2,916, and 36 times x is 36x. Divide both sides by 36, and we learn x is 81. So we know BE is actually 81. Right. The next problem is asking us to prove that these two triangles are similar. And the two triangles they're talking about is this one right here, and then this bigger one right here. So this time, we are looking at the picture, and we got to figure out what theorem would prove these are similar. Now, right away, I notice that they have the angle right here and the angle right here being congruent to each other. So angle S is congruent to angle T. They did give us some side lengths, like we could see that 8 and 12 are corresponding sides, but sadly they only give us 10 here, but they didn't give us what our T is. Now, we can't just go ahead and find it because we haven't proven these are similar. And if we can't prove they're similar, then the math that you've seen in problems today just doesn't actually work out. You're just making things up if you can't prove these two things are similar. So the only other thing that I noticed that is going to be congruent is angle R. You'll notice that angle R is in this small triangle up here at the top. And it's also in the big triangle. It's right on top of each other. They're sharing angle R. So angle R is congruent to angle R because angle R is in both triangles. Therefore, we've just proven that they're similar by AA. Once we know they're similar, these two figures, we then can go ahead and say, well, we can now solve for parts of this triangle. So down here where it says find the length of RT, so the length from here all the way to here, we now are able to do that. So I'm going to take information from the smaller triangle, this one right here. So I'll say 8 over 10. And that's going to equal information from the larger triangle. Now remember in the first fraction I pulled the 8. I pulled information from this part. Its corresponding part to the other triangle is the 12. So that's have to go in the numerator. And the length of here, which is the 10, will have to go, which is the x, will have to go on the bottom. So now we just cross multiply. 8 times x is 8x. 10 times 12 is 120. Divide by 8 is going to be 15. So we know this whole length is 15.